Dear students, today I am going to teach the experiment of the active filter design. So in that active filter design we have three filters. One is low pass filter, high pass filter and band pass filter. So first I am going to teach the low pass filter. The aim of the experiment is to design a low pass filter for 1 kilohertz frequency, cutoff frequency. So the required components for this experiment is signal generator. So this is the signal generator. This is the main power button to switch on the signal generator, and this is the on and off switch to exhibit the waveforms to the circuit board, and this is the monitor to display the waveform, and this is the sine wave, square wave, ramp wave, pulse wave, harp wave and noises that will be used to generate the signal to the input for the circuit. Regulated DC power supply. This is the DC regulated dual power supply. So this is the main switch on button to switch on this particular system. So we have two main parts here. One is this part and another one is this part. So I'm going to explain what is this part. So this is the voltage tuner and this is the current set tuner. So in the voltage tuner we have two main categories. One is coarse tune and one is a fine tune. If you want to tune your voltage to maximum level in maximum numbers, that will be used by coarse tuner. If you want to tune the voltage that in the minimum level, that will be choose with a fine tuner terminal. So if you want to set your current, that will be based upon the application, so you can set by using this current set terminal. So in our circuit we will always keep this as a maximum current, and we have two main terminals. One is positive terminal and another is a negative terminal. So positive terminal is indicated by a red color and negative terminal that will be indicated by a black color. So this provides positive and negative voltage to the circuit, and the same operations what happens in this system that will be happen with this part also. And this is the ground connection. Normally we are used to this terminal in a very large applications. This is the display that will be used to display the values of voltage and current that will be generated to the system. Digital oscilloscope that will be used to measure the output. So in this device, this is the switch on button, so to turn on this system, and we have main two terminals. These are the one terminal and these are the another terminal. So we call this as a channel number 1 and the channel number 2 that will be used to see the output. Okay, these are all the tuners to adjust the amplitude and frequency of the signal. Circuit board. So this is the circuit board or breadboard. This is used to connect our entire circuit. Okay, this is the series connection till this large gap, and again this is the series connection. So this is a series connection in x-axis, and this is a series connection in y-axis till this division that will be counted to 5. Till that it is a series connection. After that this is one connection. Resistors. For this experiment I am using different resistor segment. One is 5.6 kilo ohm resistor, 6.2 kilo ohm resistors and 10 kilo ohm resistor. Capacitors. I am using the capacitor of 0.1 microfarad. IC MU741. In this experiment I am using MU741 IC. This is the notch that will indicate the terminal numbers of the IC. From the left hand side, 1, 2, 3, 4. This is 5, 6, 7, 8. It's a total package of 8 pin IC. Connecting wires and patch cards. So now I am going to connect the circuit of active low pass filter design based upon the circuit diagram. Now I am going to connect the circuit like this. So I am taking the circuit board. So I place the IC to the circuit board. So now I am going to connect the pin number 2 to 5.6 kilohertz. This is 5.6 kilo ohm resistor I am taking. So 5.6 kilo ohm resistor that will be connected to pin number 2 to pin number 6. See, this is pin number 1 and this is pin number 2. Pin number 2 to pin number 6. This is 5 and this is 6 I am connecting here. So this will be connected to pin number 2 and pin number 6. Next I am going to take 10 kilo ohm resistor. So this is 10 kilo ohm resistor. I'm going to connect this 10 kilo ohm resistor to pin number 2 to ground. So this is pin number 2, and this is connected to ground. I am connecting here. Now I am going to connect the 1.6 kilo ohm resistor to terminal number 3. So this is terminal number 3 to somewhere in the circuit board. I connect like this, and another 1.6 kilo ohm resistor I need to connect with a series of this resistor 1.6 kilo ohm. So I connect like this. I connect this point to somewhere in the circuit board. I connected like this. Now I'm going to connect the capacitors. One capacitor is from the terminal 3 to ground. So this is terminal number 3. Terminal number 3 to ground I need to connect. So this is terminal 3 and this is ground. Another capacitor I need to connect to the pin number 6 to the pin number 3. We have connected 1.6 kilo ohm resistor. So middle point of this junction I need to connect to pin number 6 with a capacitor. So like this is the point. So I need to connect this point to pin number 6. This is pin number 6. Now both the terminals will be connected. Now I am going to connect the input signal to this circuit using the patch card. So I am taking the patch card and I want to fix the patch card like this. So I provide the input for this first. I am taking the wire. The positive end I will give here, and the negative end I made to ground. This is the ground connection. Next I am going to connect the DC regulated power supply. The positive end of the DC regulated power supply will be given to pin number 7. So this is giving like this. This is pin number 5, 6 and this is 7th pin. I connecting here. The negative end that will made to ground. Made this to ground, and another positive end of the DC regulated power supply is connected to ground. And the negative this supply will be given to the pin number 4. So this is pin number 4. Connecting here. Next I am going to connect the output. I am taking other patch cards. First I am going to connect the input terminal by using a patch card. This is I am using for the input. So positive end of this will be connected like this. I will give the positive terminal this to input point. So this is the input point, and the negative I will make to ground. So this is the ground connection. I am taking another patch card to see the output. The positive end I will give on to the pin number 6. This is pin number 6, and the negative end given to the output ground. This is ground. This completes the circuit connection of active filter design. This circuit is designed for low pass filter design for 1 kilohertz frequency. So I'm going to switch on this signal generator to give an input for the circuit, and I'm going to switch on the digital oscilloscope to see the output of this circuit. I'm going to switch on this DC dual power supply to provide a voltage to the circuit. So we need to set this to 12 volt, whether it may be any voltage, but we must set this both terminals to 12 volt. It's already set it to 12 volt. Now I'm going to vary the frequency from 100 hertz to some 1 kilohertz. So here this is the knob I can use, otherwise we can set this like this, 200 hertz peak to peak I given. Still I am getting 3 volt peak to peak at the output. 300 hertz, same, the frequency will be varied but the amplitude will be the same, 3 volt peak to peak. Some 400 hertz also, three volt peak to peak. I changed to some 600 hertz. Now you see the amplitude will be slightly decreases to 1 division, 2 division, 2.3 volt peak to peak it have, because some I'll put some 500 hertz. So exactly it shows some 2.8, 400 hertz, it will shows 2.8, some 300 hertz, 3 volt peak to peak. Likewise you can check the various frequencies. Directly I'll go to some 500 hertz. It will show some 2.8 volt peak to peak. 600 hertz, 2.8. Some 800 hertz I will put. See, drastically it will be changed. It will give some 2 volt peak to peak. Some 0.3 will be reduced. Again I will put 1 kilohertz. See, complete change. Some 1.2 volt peak to peak it will be available now. If we change to some other values, some 1.3 like that, it drastically decreases the output like this. If the frequency will be varied, the amplitude of the signal will be get reduced. So we can conclude that the low pass filter that will passes the signal up to some critical frequencies. After that the output signal will get reduced. So here the critical frequency is 600 hertz, because after 600 hertz the output will get reduced. So this completes the experiment of low pass filter design. Dear students,